Nabila, you've got it.
I'm actually going to cede my time to my husband, Rehman, who's also...
That's our policy doesn't cede time.
We weren't sure if he was going to make it, and
I mean, he did make it. He signed up, so for 3 minutes
he couldn't sign up in time because he arrived late tonight. He's a resident of Willowbrook also. He'll only talk for 3 minutes.
You know what? Only because other people are signing other people up using others' names, and until we clarify that, I think that's fine.
Hi, my name is Rehman. I'm a director of a PhD program of cell biology and regenerative medicine at the University of Illinois, Chicago, and I'm also a cardiologist. And I lead a research group of about 15 scientists. We study cancer biology, we develop computational algorithms, Alzheimer's disease, and stem cells. And I thought it might be good to have a university professor's perspective on how to have a proper sequence of science education. And the speakers before me have already really nicely explained that it makes a lot of rational sense to teach physics first, chemistry second, then biology, because that's just the nature of the matter you're teaching, the content. You start from forces and simple atoms, you build on it by developing knowledge on molecules, which is chemistry, and then molecules put together develop cells and biology. But I think one thing that the other speakers haven't mentioned is the nature of how we teach. So even when I teach biology PhD students, I still go back to physics principles, because the way physics evolved was it was a very simple hypothesis-driven science, even back to the 17th, 18th century. And you can teach science better if you start with simple quantitative principles. So if you're just trying to cram facts of biology into curricula, it probably makes no difference what you start with first. But if you want to teach students proper quantitative reasoning, it's better to start with a science that is built on quantitation, such as physics and chemistry. So then you have a foundation for how do you even approach science? How do you test hypotheses? How do you make measurements? How do you empirically test a hypothesis in a lab, which is much easier to do in physics and in chemistry than it is in biology. And if you do it the right way, your understanding of biology is much, much deeper. So I think the sequence, it's not a trivial thing. It's not just about how many facts you convey or how much memorization you do. It's about the manner of teaching. And physics is really the queen of science. This is how we see it, and this is how even as biology professors, we keep on coming back to it. That's how we illustrate how students should develop critical thinking and hypothesis testing, even at the university and postgraduate level. So, thanks.